Welcome to SS2 Mathematics. This lesson covers functions, focusing on domain and range, fundamental concepts in algebra and calculus that describe what values a function can accept as input and what values it can produce as output. These concepts appear in WAEC mathematics and further mathematics. A function is a rule that assigns to each element in a set called the domain exactly one element in a set called the codomain. Think of a function as a machine. You input a number, the machine applies a rule, and it outputs exactly one result. For example, the function f(x) equals x squared takes any real number as input and outputs its square. If you input 3, the output is 9. If you input -3, the output is also 9. The key property of a function is that each input gives exactly one output. If an input gives two different outputs, the rule is not a function. We write functions using function notation. F(x) equals some expression in x, where x is the input and f(x) is the output. Functions can also be written as y equals some expression in x. The domain of a function is the set of all valid input values for which the function is defined. When finding the domain, look for values of x that would make the function undefined or produce non-real outputs. Two main restrictions. First, division by 0 is undefined. If the function contains a denominator, set the denominator not equal to 0 and exclude those x values. Example, for f(x) equals 1 divided by x minus 3, the denominator x minus 3 cannot be 0, so x cannot equal 3. Domain, all real numbers except 3. In interval notation, -infinity to 3 union 3 to positive infinity. Second, square roots of negative numbers are not real. If the function contains a square root, the expression under the root must be greater than or equal to 0. Example, for f(x) equals the square root of x minus 4, we require x minus 4 is greater than or equal to 0, given x is greater than or equal to 4. Domain x greater than or equal to 4. For polynomial functions, those with no denominator and no root signs, the domain is all real numbers. The range of a function is the set of all actual output values the function produces when the domain is applied. Finding the range is often more complex than finding the domain. Method 1, algebraic rearrangement. Let y equal f(x). Rearrange to express x in terms of y. The domain restrictions on y that ensure x is real give the range. Example, f(x) equals x squared for domain all real numbers. Set y equals x squared. Then x equals the square root of y, which requires y to be greater than or equal to 0. Range, y greater than or equal to 0. Method 2, graphical reasoning. Sketch the graph of the function and observe which y values are achieved. The range is read from the vertical extent of the graph. For f(x) equals x squared, the parabola has vertex at the origin and opens upward, so y is always greater than or equal to 0. Common ranges, linear function, range is all real numbers, quadratic in the form a, x minus h, squared plus k, range is y greater than or equal to k if a is positive, or y less than or equal to k if a is negative, reciprocal 1/x, range is all real numbers except 0. Composite functions arise when the output of one function becomes the input of another. If f and g are two functions, the composite f of g of x, written as f of g x or f composed of g x, means, first apply g to x, then apply f to the result. Example, if f(x) equals 2x plus 1 and g(x) equals x squared, then f(g)(x) equals f(x squared equals 2x squared plus 1. And g(f)(x) equals g, 2x plus 1 equals 2x plus 1 squared. Note that f(g)(x) and g(f)(x) are generally different. Composition is not commutative. The domain of a composite function f(g)(x) consists of all x values in the domain of G such that g(x) is in the domain of f. Today we covered that a function assigns each input exactly one output. The domain is the set of valid inputs, exclude values causing division by 0 or negative square roots. The range is the set of actual outputs, find by algebraic rearrangement or graphical reasoning. Composite functions apply functions in sequence, f, g, x applies g first then f. For your practice exercise, find the domain and range of these functions. First, f, x equals 5 divided by x plus 2. Second, g, x equals the square root of 9 minus x squared. Third, h, x equals x squared minus 4x plus 3. Then for f, x equals 3x minus 1 and g, x equals x squared plus 2, calculate f, g, x, and g, f, x.